In this video, we'll be talking about two types of logarithm problems. The first type is the equation simplifies so that there are logarithms on both sides of the equation. An example would be this one. The log base 4 of x plus 2 is equal to the log base 4 of 5. Now, when you have a simple logarithm on the left side and a simple logarithm on the right side, and they both have the same base, in this case it's base 4, then we can say that the arguments are equal. So all we need to do then is write the argument that's on the left side, x plus 2, is equal to the argument that's on the right side, which is 5. Solving for x, we subtract 2 from both sides, and we see that x is equal to 3. The other type is when the equation simplifies so that there's logarithms only on one side of the equation. For example, here we see the log base 4 of x plus 2 is equal to 2. So we only have a logarithm on the left side, not on the right side. In this case, we need to write as an exponential. Now recall that the rule is basically the log base b of some argument equals x can be written as an exponential by taking the base of the logarithm and raising that to the exponent. Remember, a log is an exponent, so this is my exponent, and that equals a. So that's my rule. So my logarithmic equation then becomes the base 4 raised to the second power is equal to the argument, which is x plus 2. Now we know that 4 squared is 16. Isolating our x, we're going to subtract 2 from both sides, so that x is equal to 14. So let's do an example. Our problem is we need to solve 3 log base 10 of x equals log base 10 of 16 minus log base 10 of 2. So we need to use our property of logarithms that says the difference of the logarithms is equal to the log of the quotient. So this right side simplifies to the log base 10 of 16 divided by 2. We can also simplify the left side by taking this coefficient up as an exponent on the argument. So this left side is the same as the log base 10 of x to the third power. So now that we have a log on the left side and a log on the right side, we can say that the arguments are equal. So we have x cubed is equal to 16 divided by 2. Well, 16 divided by 2 is 8. So now we just need to cube root both sides. The cube root of x cubed is x, and the cube root of 8 is 2. Let's do another example. In this example, we want to solve log base 7 of the quantity x plus 1 plus the log base 7 of the quantity x minus 5 is equal to 1. Now the first thing we want to do is simplify this left side. We know that the sum of the logarithms is the same as the log of the product of the arguments. So this is the same as the log base 7 of x plus 1 times x minus 5. And that's equal to 1. Now we can notice that this logarithmic equation only has a logarithm on the left side, not on the right side. So we need to write this as an exponential. So that means that 7 raised to the first power is equal to the argument. 7 to the first power is 7. We need to multiply this out, so using FOIL, x times x is x squared. X times negative 5 is negative 5x. 1 times x is 1x. And 1 times negative 5 is negative 5. Combining our terms and subtracting our 7 over to the other side. Since we have a quadratic, we need to get ready to either use factoring or quadratic formula or completing the square to solve. This gives me 0 on the one side, and then we have x squared. These two terms combine to give me a negative 4x. And then this is negative 12. I think this trinomial factors. So we need x in the first spots. We need two terms that multiply to give me a negative 12 and add to give me a negative 4. So I think a negative 6 and a positive 2. Because negative 6x and a positive 2x is negative 4x. All right, now that we have that factored, then we can set each of these factors equal to 0. X minus 6 equals 0 gives me x equals positive 6. And then this one, x minus 2 equals 0. Add 2. Oh, that's x plus 2, sorry. X plus 2 equals 0. Subtract 2 from both sides. So these will cancel. X equals negative 2. Now on this type of problem, we need to make sure that our argument is positive. So on our problem, if we put a negative number in here for x, say x is equal to negative 2, if we put a negative 2 in here, we're going to get a negative argument right here. So our negative 2 will not work, but the positive 6 will.